times, get the third person, right?
And then the third is 0.
0. Exactly, cool.
0 out of 98.
So the whole probability is 0. It's kind of silly. If I have a bag and there's 2 red poker chips and 80 other chips, I don't care, what's probably I get 3 red in a row if I don't put it back in? Can I get 3? Here's 1 red, yay. Here's another red, yay. Is there any more red in there? So what's probably I get 3 in a row? 0. You can't get 3 in a row because there's only 2. It's the same thing here. You're picking 3 people, and there's only 2 of those people there. If I don't do it with replacement, it's a 0 chance. So the math, thank God, shows me that. I eventually run out. Cool. Yeah.
Can you finish up the problem?
Oh, which one? This one?
Yeah.
Where was that at? Oh, how many women are there? So, probability of a woman making a challenge. This whole thing is, right? How many women are there? 350, right? 350? Out of how many people?
839.
839. Yay.
417.
So if you wanted to, remember that's not man. So it's probability of man. How many men are there? 489, right? 489 out of 839. So if I want to get that, wouldn't it be 1 minus this? And isn't 1 minus that, isn't it just going to make 839 over 839 minus this? I mean, 1 minus 49 out of 839, blah, blah, blah. 839 minus 49, it's going to be how many women, right? Of course, if there's 489 men, how many women are there? 839 minus that. So you see the math is matching up, because how would I subtract those? Get the LCD? That'd be 839 over 839 minus 489 over 839. But of course, it's just 839 minus 489. Total people minus men must equal women. Right? Okay. But it's just so much easier just to do it straight, right? Yeah.
Can you go back to number 18 on 4.4? And for A, it's supposed to be at 3 over 100 plus 0, 100, 100. Are you
For A, now be careful. For A, it's going to be what out of 100?
2.
2. Why is it 2? How many people are group B and RH negative? How many people are group B and RH negative? 2 people. So, listen up, guys. So, I researched this. So I know, I can't remember who told me this, but I'm pretty sure the research all says is 11% left-handed. Does that change if I take 3,000 people and say, let's probably get 500 left-handers? Does that somehow change the fact that 11% of the population is left-handed? Just picking some people, I change, all of a sudden somebody's left-handed, put the right-handed now. No, of course it's still 11%, right? So just because they say pick 3 people, 3 out of the 100 people are randomly selected, I don't care how many people I'm picking. What is the probability that anybody is group B and type RH negative? 2 out of 100. Why? Because only 2 people are B and RH negative.
So you just multiply it 3 times?
Exactly. What's that 3 represent? 3 spots. And you put the probabilities in each.
But what would you do for B? Would it just be 2?
That was a question from earlier. That third one is going to run out.
Right, so put them
So let's see how this will look. So sometimes good to just kind of do a little side thing here. What was this? This is number 18, right? What's the probability of B and RH negative just by itself? We just said that a second ago, right? 2 out of 100, because there's only 2 that match that description out of 100 total people, right? Now, if I want to know the probability of getting 3 that are like this, that's 1 spot and another spot and another spot. So sure, if I do it with replacement, each one of them is going to have a 2 out of 100 chance. Because I pick somebody and then I put them back in. I pick somebody and I put them back in. Must be really tiny. Woo! Right? So 2 out of 100 chance, 2 out of 100 chance, 2 out of 100 chance. No problem. That's part A. Because part A is with replacement. With replacement's awesome because all the probabilities stay the same. I don't care what you just did because you put it back in. The minute I don't put them back in, that's part B.
Well, what's the answer to that?
Oh, whatever the hell that is.
Well, there's
What's point 0.02, 0.02, 0.02?
0.06.
No, don't add them, multiply.
008.
Well, 0.02, 0.02 is 0.0004 times 0.02. Right? 0.02, 0.02 is going to have 4 places. Cool. Good Lord, right? And you can just do that in your calculator as I pass away. Cool. And that's the old, when you multiply decimals, you got to add up how many places your answer is going to have. Remember that stuff from a million years ago? Probably not. Uh-oh. All right. And then part B is going to look like what? So this is going to be without replacing. The first guy, everybody's still there.
So then would it be 1 out of 99?
Exactly. Because now there's only 1 left out of 99. And the minute I pick him, how many's left? 0 out of 98. So of course it's 0%. Right? If there's only 2 winning numbers in a lottery, what's probably 3 people will win? 0. Right? There's only 2 people in that match what I'm looking for. If I don't allow it to happen again, if I don't replace it, there's a 0% chance. So some of you guys, if you really looked at it, you could tell without doing any math. Oh, that's going to die. I'm going to run out of people. Why does part A not run out of people? Because I keep putting it back in the room, right? I don't take them out. I always have the same number of people and the same number that match what I'm looking for. Okay. Maybe.
How did you get the 0.0008?
Well, in your calculator, you just do 2 divided by 100 times 2 divided by 100 times 2 divided by 100.
I did better.
What do you get? You get 8e negative 6.
Oh, yeah.
And that's 8 times 10 to the negative 6, which means move it back 6 times.
Can we just do that answer? Like the 8 -6?
No, figure out what it is. It's a decimal. To make you guys review your algebra. Yeah.
What section is it?
18, this is section 4.4.
Jeff, can you do 24 on that same section?
Let's see. Oh, okay. So 9 different crime victims listened to voice recordings of 5 different men. This kind of problem is the problem I expect questions on because it sounds like there's too much going on. So we need to separate out what's really going on. Sort of like what we did here. I got 9 different people going to make choices here, right? That's sort of like picking 3 people. That's just telling me how many spots I've got. What's the central probability going on? If I got 5, where'd it go?
1 out of 5.
5 different men, and I just randomly guess what's probably get it right. If there's one dude that did this crime, let's probably get it right. If I got 5 different guys' voices, and there's one guy that's the right one, what's the probability I picked that one? 1 out of 5, right? One guy that matches what I'm looking for out of 5 things. Cool? So probability of picking the right guy at random equals 1 out of 5. I like this problem a lot. And I'll show you why here in a second. So do you see how to you figure out what the central probability is, and now you can do, now here's where you got to be a little careful. Where'd it go? Where'd it go? I keep losing.
5 or 9.
All 9 victims select the same person. Now this problem is a little, it's not 1/5 to the 9th. And I'll show you why. The first guy, who could they pick? Let me see here. There's 2 different ways to explain this. I really want you to understand. So there's 5 guys. And they can pick anybody they want to, but I want to know the probability that they all select the same guy. So if you do 1/5 to the 9th, that's assuming a little too much. That's being very specific. Well, I want that guy to be the one. Well, how many guys could it have been? 5 of them. So you actually got to multiply that by 5. So it'll cancel with 1. You actually get 1/5 to the 8th. Right? Because it'll be 5 times 1/5 times 1/5 times blah. One of them cancels. You guys see that? That's one way to look at it. I think a better way is the first guy picks whoever the hell he wants to. So what's the probability he picks the right guy? 100%, because he's the one setting the tone. He gets to pick whoever he wants to. Now what's probably the rest of them agree with him? 1/5 to the 8th. Either way you look at it, that's going to be the probability. Now what is 1/5 to the 8th? 1 divided by 5 to the 8th power.
256.
It almost doesn't matter, just as long as it's really small. So now watch this. That's the probability that 9 guys will randomly select the same person as the guy they think it was. So if I get 9 guys and they do pick the person, they all pick the same person, what's more likely? That they just happen to randomly pick the same guy, or that that's the guy? Which one's more likely? That's the guy, because how likely is it they did it just randomly? Pretty damn unlikely. We're talking stupid unusual here, right? How close is this to 5%? Not. Do you guys see how important that idea is, though? It's important to know how many people you got to agree on something before you start going, maybe there's something to this. So if 2 people pick the same one, what's the chances they randomly selected? 1 out of 5 chance, believe it or not, right? And what's that? 1 out of 5, that's 20% chance. So if 2 people both say, yeah, it's that one, that's not enough for me to go on. I can't present that in court. The judge knows a damn thing about statistics. He'll say, well, that's bullshit. What else you got? But if I go in there and say 9 guys all said the same person, especially if it's the one that the prosecution thinks did it, then hey, what the hell? That's evidence, man. That's monster evidence. Beyond a reasonable doubt. Right? That's what I love about statistics. We're almost to the point where you can really sink our teeth into real life applications of statistics. That's pretty damn close to it. That's almost what they do in a lot of these cases, right? They want to make the case that it's so improbable that what must be true is he did it. Not that they all just happen to pick, but he did it. That's what's more likely. Yeah.
Can you explain again really quick how you got the 1/5 to the 8th? I don't get that at all.
Well, all right.
I can ask you a quick question.
No, real quick. So I got 5 guys who all recorded their voice, right? Right? So what's probably they all picked the first guy. 1/5 to the 9th. Or they could all, you guys with me? Because I mean, the first thing out of your mouth was almost right. 1/5 to the 9th. I understand where they come from, but that was being way too specific. What's probably they all picked the first guy. Was a 1/5 chance any of them picks the first guy. So it's the chance they all pick the first guy, 1/5 to the 9th. Or they could all pick the second guy. You guys with me? So I want them, all 9 of these guys, I want the first guy to pick the first guy. I love this problem. I want the first person picking to pick the first guy. I want the second person picking to pick the first guy, and so forth. And that's why we get 1/5 to the 9th. Or, and what does or mean in probability? Add. And means multiply. Or the second guy, the same reasoning, it's the same number, right? There's a 1 out of 5 chance that I pick the second guy, and a 1 out of 5 chance that she picks the second guy. All 9 of us pick the second guy, 1/5 to the 9th. Or the third guy. Or the fourth guy. Or the 5th guy, right? And what is that added up 5 times? 5 times that, of course, right? X plus X plus X plus X plus X is 5X. And don't one of those 5s cancel? So I understand it's a really It's a really minor detail that's easy to miss.